Welcome everyone. So today's lesson we're going to be exploring energy and in particular both kinetic and potential energy. So if I think of when I came to school today, at various times I experienced or was exposed to energy, different types of energy. So an example for kinetic energy would be when the car was in motion as I was on my way to school. Because we define kinetic energy as being energy in moving bodies. So something that's moving through space is kinetic energy. So what do you think are some examples of kinetic energy? Yeah, throwing a ball out in the field, that's a really good example. Yes, moving the chair when you came to sit down. So there's many different ways that we can observe kinetic energy. And the other key type that I'd like you to learn about and explore today is potential energy. And what potential energy means is that it is stored energy. So if you think of the branch in a tree, it's just sitting there, it's not moving. But if it was to break and fall, there would be a lot of energy released. So there is potential energy, stored energy in that branch due to the effects of gravity. So gravity would draw it down. And that would only occur though and turn into kinetic energy, again being moving through the air, once it was broken. So it's a really important differentiation between those two types of energy. And we're going to explore that in a range of different ways today. So firstly, what I'd like each of you to do is just to grab a piece of paper out of your workbook, and I want you to scribble down earlier this morning, from when you've woken up until you arrived here today, is to write a bit of a list of different types of kinetic and potential energy that you actually experienced or saw. So I'll give them maybe 3 or 4 minutes to do that. Bringing the class back now. Okay, what I want you to do is to actually throw them all into that corner. So we're just going to pop those, wrap them up to a little ball, chuck that piece of paper in that corner. We're going to deal with that a little bit later in the class. Before we do, what we're actually going to go through is a couple of experiments. So the first experiment is we're actually going to build a marble run. And you've got some materials up here at the front in your groups that we used last lesson. In a moment, I want you to come up and to grab the different materials here and build a little bit of a marble run. Now, the key factor that I want you to consider is to grab a few marbles of different sizes, and I want you to observe and record the differences of what actually happens. So if you use a small marble, what happens? And then if you use a bigger marble, what happens? And I want you to relate that back to what we were talking about a little bit earlier with regards to the differences between potential energy and that kinetic energy. So I'm going to give you about 15 minutes to build those marble runs and just observe the differences that you can see, and then we'll come back and have a bit of a discussion about that. So coming back, I would then talk through with the class the differences of what they would observe. So what they would have noticed is that the heavier marbles go further, reason being that they've got a greater level of stored energy, and once they're released down the same marble run, they're going to travel further due to that greater level of stored energy. The second experiment that I'll be taking them through is going to be the Apple pendulum. So in the same groups, I'm going to get the class to come up, and they're going to actually tie. They're going to get 1 apple each. So there's maybe in groups of 3 they'll be in. 1 apple each, so 3 apples, some string to attach to one of the apples, just one, to build a bit of a pendulum. And they need to bring the pendulum with the apple up against their forehead, and from there they're going to release it, and they're not allowed to move. So when it swings back, I want them to observe whether it does hit them in the forehead, and if not, why not? What's actually taking place? What they'll find from this experiment is that it won't. Otherwise I wouldn't let them do it. But the reason being is the effect of gravity. So gravity actually dissipates that kinetic energy through the movement, so it will slowly slow down and come to a stop. So I'll have a bit of a discussion about that. I think some of the students would pick up on that being the reason, but it's a bit exploratory for them. Now, the next thing that we're going to do is the last part of the class is to actually take the group outside. And as I'm preparing them to go outside, I'm going to ask them to actually consume the apple, because they had one each, but they didn't need to use them all in the experiments, and this is where that comes through. As they're walking outside, I want them to consider that when they're consuming that apple, what sort of energy is being consumed? How is that energy being used in the body? And I would ask them to reflect on that, and also to link it to their PE classes, so they'll learn a little bit about health and diet, and just discussing where this energy comes from within the food and how it's used by the body, being changed from potential energy in the apple to kinetic energy where it's actually being used in the body. So I thought that'd be a really nice example relating it to their personal lives and also another subject area. So once we're outside, they're going to get to spend 5 minutes just observing the environment around them and identifying key potential energy and kinetic energy as well, and write up a bit of a list in terms of what they do observe. And again, this is relating the theory to their personal lives. So then hopefully when they walk home this evening or after school, they might actually think about, oh, there's some potential energy, there's some kinetic energy, making it again relevant to their own lives. And once we finish the little task outside, we're going to come back inside and have a broad discussion about that. But just prior to the broad discussion, actually, what I will get them to do is each to go up and pick up one of the idea balls, it's a little ball of paper, unwrap it, and have a look through and contemplate and consider the types of energy that were written down by other students. And again, coming back, how we'd finish off with that class-wide discussion. And I would want the focus here to be on relating it to their lives and relating it to other subject areas. So one example that would likely come up, or if not, I'd probably stimulate discussion with, would be around footballs and basketballs. So, we have a lot of stored potential energy in the basketball or football where we're holding it, and then that turns into kinetic energy when we drop it due to the effect of gravity, or also when we kick it or pass the ball. So a lot of kids do like sport, so that would be a good example for that. And I'd also want to link it to humanities. So in Year 8 in humanities, they learn about, or a cross between humanities and science really, they learn about the effect earthquakes can have on society. That's one of the tasks which you can do. And I would ask them to think about, well, in relation to earthquakes and the fact that it can be devastating for society wherever it occurs, what sorts of energy exist in that circumstance? Is it potential energy? Is it kinetic energy? And when does that change? So hopefully them gaining an understanding that there's a lot of potential energy built up there, and then it's released as kinetic energy in what can be a really devastating natural disaster. So again, hopefully linking it to some other areas of the curriculum and which they're learning about in their Year 8 classes. So that would be the class that I would run, which would cover potential and kinetic energy.